So this is our lecture series, gonna be lecture series 4. Just an overview. Let's see what did we do last week and how many of you still remember it, right? So previously, I don't know, can you see me? No, but you can see the screen, right? So what did we do previously? We, in this lecture series, we talked about previously in this lecture series, we talked about how to describe qualitative data. First, right? Let me go behind just for you to have an overview, right? We talked about how to describe qualitative data, that is through tables, through graphs, and through numbers. And when we talk about table, it can be one-way table, two-way, or n-way tables. And when we talked about graphs, okay, that's a quantitative, that's not qualitative. That's a qualitative. So we talked about one-way, two-way, how to present the qualitative data into tables. You know, one-way is just one variable. That's, I gave you the example of gender with male and female. Two-way table, like you can also add up the example what we have learned was about like manager's job level, if it's like a manager level or clerical level, then how many females doing the manager level job, how many females doing the, so mostly we show these numbers into percentage, right? And then we graph these numbers into a bar chart, pie chart. Bar chart is to comparison, pie chart is to for share, to show the share. We can also use the donut chart. Donut chart is also like is a kind of a pie chart, but we do it like share like this. This much share for one stock. This much share is for another stock, stock B. This one share for stock C, and this one share for stock C or D, the investment. So this is kind of a donut, like eating donut. And that's how we present the qualitative data. Then we learned about the quantitative data, that is also through tables, graphs, and numbers, where there we learned that how to make frequency distribution along with its features and importance in statistical analysis. We also learned how to give a graphical presentation, that is through histogram, right? Which basically shows us the shape of the distribution and locate the midpoint of the distributions. Later we came across with another tabular form, that's a stem and leaf plot, where we just divide or distribute the data into stem and leaf, and basically this also shows us the shape of the distribution. And it's when we saw the example, it generally showed the almost the same picture, almost the same shape as of histogram. Then we move to numbers, right? And in numbers, how to describe the quantitative data, that's really important. First, we learned about the central tendencies, which means averages or means. We also call this averages, right? Um, there are certain averages. We learned that mean, geometric mean, and harmonic mean. Harmonic mean is a reciprocal of a mean. We can show mean with the X bar. It's also known as arithmetic mean. So we see that these averages, they are really biased towards the outlier. That is, if there is a huge number, one outlier, For example, in my class, everybody was like taking numbers like 60%, 55%, 65%, 70%. Mostly they took their numbers in the within the range of 50 and 70. So average is around 67%, right? That's example. But one student, he got 100%. So that means that student is an outlier. How to interpret that outlier? That one student is genius in my class, and another student, he got like 10%. So he's also outlier on the other side. So it's like if it's in a symmetry, so this is mean x bar. So mostly data lies here, but one student, he got here as well, right? We know how to get this distribution, right? This shape. We just draw a different histogram. So these are the histograms basically, right? And there's one outlier here, right? So he's a genius because he got 100. So mostly students, they got like from 50 to 70, but one student, he got 100. So he's a genius. So if there is an outlier here, so he's also the extreme on the other side. Means he's not so good student. He's dull-minded. He or she is a dull-minded student. So that's what arithmetic that's what the outlier can tell us. And we saw that among these three, there there is a possibility that whenever there is an outlier, they affect these three averages, which means they are not so efficient if there is an outlier. So if there is an outlier, then we learned about median and mode, right? So what is median? Median means you just get the midpoint of the data. So it doesn't matter if there is an outlier in the extreme sides of the data. So if you have data like 8, 9, 5, 4, 3, 102, then of course 3 is the midpoint of the data. So we will consider median just 3, and 100 will automatically be out of the average. So that's how we calculate median. We learned about this, and I'm sure you have revised at home, and today we will discuss. Similarly, mode. Mode means we arrange the data and we will see that which number is repeating how many means mostly. So if one number is repeating a lot, means 3 times, and rest are like just 1 time, 2 times, then we call that the one who is being repeated mostly. That's mode. But in mode, sometimes there is a problem. Sometimes 2 numbers can be repeated mostly. For example, if we have data like 8, 11, 11, 9, 9, 7, 10. So in this data, 9 is repeated twice, 11 is repeated twice. So we can have 2 numbers as a mode. So in this case, we just take an average, that we take 11 plus 9 by 2, which means 10. So here the mode will be 10. So we learned these. These are the measures of central tendency. Central tendency means midpoint, mean, averages. Today we will discuss first how to measure the important points. That is again median, quartiles, deciles, percentiles. Little bit we talked about this I think in previous class, but today we're gonna learn more in details. What is the meaning of important points? Why do we need it? That's what we're gonna learn. And then second thing, we're gonna learn how to measure the variation. Variation means that how much one variable is away from the mean or from another variable, from another data point, sorry. So we can also call measure of dispersion, measure of variation. And then we will talk about the distribution of the data. The data can be distributed into 2 parts, skewed and kurtosis. If we will have time, we will go further, and in between we will try to include Excel sheet so that you can see directly in Excel how to solve problems. And most probably you should know about different formulas we use in Excel, right? So we can, okay, I thought maybe you have some question. So we can just skip the last time class and we can start now. From here, again, because these two, because today we're going to talk about this, so we're going to start with this. So we already know the central tendencies, right? So what do you mean by, what do we mean by important points? Again, median, we already know, right? For example, this is the score of 6 students in a quiz. We are just using the same example. And what will be the median? So this is a 6. 1, 2, 3, 4, 5, 6. So I can take these two mid values because it's even. So and I will take average. So 9 and 8, it will give me 17, which gives me. So here median will be 8.5. Right, so that's our average in this case. Why do we need it? Because look, if we have a symmetric distribution, so we divide, yeah, this one, if we have this one, then this can be a median if there is an outlier. Remember, we use median and mode to get away from the outlier impact to the data. So we know how to calculate medians. So let's go how to measure quartiles. But before that, you need to understand that what is quartile. So quartile, for example, this is the data set. We have data dispersed here, right? This is different data. These are points, right? So if we draw the distribution, it is like this. So we can say, okay, we distribute the data into 4 quarters. That is Q1, Q2, which is also mean. Okay, I'm gonna use the camera. So let's move a little bit in this direction. All right. And let me move the chair as well so that everyone is in a comfort zone. Now, let's say you can see, right? So this is the distribution, and what is distribution is this? It's a symmetrical distribution. Symmetrical distribution means the data is dispersed. I mean, the data is the distribution, the histogram is distributed in such a way that midpoint is a mean, right? Average. So that's symmetrical distribution, and when we take an average, it gives us into 2 equal halves. So now we divide this into Q1. And the midpoint, which is also mean, something like that, right? Q2, and here Q3. Now we divide this distribution into 4 equal quarter. So this is 25% of data is here, 25 is here, 25 is here. of data, and 25% is here, and 20% is here. So remember, the area under the curve is equal to 1, okay? So if we add up all the 25%, it gives us 1, means 100%. So the data, all the data points lies under this area. So how to calculate the quartile? Simply Q1, remember, n plus 1 upon fourth value. So Q2, 3, 2. This is one value, this is 2. N plus 1 upon fourth value. Q3, 3, n plus 1 upon fourth value. What is this? How do we interpret it? Just give me a few seconds, so then I will tell you. So can I say that this is n plus 1 by fourth value? Yes, I can say that. Of the distribution, right? And this, I can say n plus 1 by 2th value, which is also mean, right? So Q2 is the mean if the data is symmetrical. Even if the data is not symmetrical, then we can have this formula to calculate the mean. And this one is as it is, 3, fourth value. So we have to calculate Q3 and Q4 because for that we need to arrange the data set. Let's say we have a data 8, 9, 9, 9, 10, 11. So in this case, what is the Q1? So now we arrange the data in ascending order. This is the same example as you can see from the slides. You can see from the previous lecture slides. Now I arrange the data. So what is the Q1? So Q1 will be, how much is n? N is 1, 2, 3, 4, 5, 6. So Q1 will be 6 plus 1 by 4, which is 7. If I draw this, it is 7 by fourth value, which is 3 point something. No, 1 point something. 1.75th value, which means that Q1 lies between, this is first value, and 1.7 is a second value, 9 is a second value. So this is first value. And this is really important to understand. And this is second value. So what is the Q1? So Q1 is 1.75. So this is not a number, it's a value. So it means Q1 lies between 8 and 9, somewhere here, right? So to get the exact value, what we can do, we can use, okay, I'm going here. From here, I'm going here, okay? Okay, maybe more up. So now, to get the exact value, now we know that Q1 is between 8 and 9. So first value, first fraction part which is 5.75. This is fraction part, right? 0.75 times second value minus first value. Remember this, right? This is how we calculate exact number. So what is the first value? 8. What is the fraction part? 0.75, right? This is the fraction part. Times, what is the second value? Second value is 9. What is the first value? 1. So what is it? It's 8 plus 0.75. Oops, sorry, it's 8, right? And into 1. So it can give us 8.75, exactly the Q1. Do you understand? Have a look. So I give you a few seconds. Now, what does that mean? Because we know that Q1 is a 25% of data. Q2 is 50% of data. Q3 is 70%, 75% of data. And Q4 means the whole area is 100%. So what does this mean? 8.75. How to interpret 8.75? It means that at least 25% of the students achieved 8.75 marks or less. I repeat, it means when Q1 means 25% of the data are means got like Q1 points or less than Q1 points. Do you understand? Like in my class, if there are 10 students or like 50 students, let's say 50 students, right? So in among 50 students, what is the 25% of 50? Almost 12.5, but we cannot divide the students, right? So what we can do, let's say 12 students. So 12 students got a Q1 value or 8.75 or less marks. So do you understand? Have a look, because it's really important to understand. Because same thing we're gonna do for Q2. So let's say let's talk about Q2, and we will also see that how it is exactly like the mean, because our data is symmetric. So if the data is symmetric, it's really exactly like a. So what is Q2? N plus 1 by 2's value. So here n is 1, 2, 3, 4, 5, 6. So 6 plus 1, 7. 7 by 2. So Q2 is 3.5 value. So what is the first value? 1, 2, 3. So this is 9. What is the fifth value? Oh, next value. So we know that our data point lies between these two nines. So we can again use to get the exact value, we can use the first value. First value is 9. Now decimal is 0.5, right? Plus 0.5, and then this is a fraction part, and then we can have second value, which is in this case again 9 and minus 9. So it means this term will be 0, and the mean is. Now if you calculate median, so here median is the midpoint. 1, 2, 3, 4, 5, 6. So 6 means between two mid 2 points, we can take average and we can get median. So do you understand? Now you have to calculate Q3 from this example just to practice at home, right? So you can tell me in next class that what will be the Q3 and how to interpret. So it means 50% of the class gets 9 marks out of 10 out of 15 or less than 9. So 50% of students lies here. Do you understand? So that's the meaning of quartiles. Have a look on it. Remember, we already know. So I'm going to erase this. You already know how to calculate median. So I don't need to, maybe I just repeat it in a quick way. First step, arrange the data. If I have different data, like same data, 8, nine, 9, 9, 10, 11, example, right? And it's randomly, right? 9 is here, 8 is here, and 10 is here, and 11 is here, and 13 is here. So just random numbers, any random numbers. So we can arrange the data accordingly. So it will give us 8, 9, 9, 9, 10, 11, 13. So this is the range form. So what will be the median? So this is the first step, arrange the data. Then second step, what will you do? Check the number of values, that is odd or even. So 1, 2, 3, 4, 5, 6, 7. In this case, it's odd, right? So you check the n. If n is odd or even. If it's odd, then midpoint. In this example, 1, 2, 3, 1, 2, 3. So this is the midpoint. If it's even, then average of 2 midpoints. Nine and 10, so it will be 9.5. Right? So center two values. This won't affect the outliers. If some data is here, it could be get out from the thing. Similarly, we can go for mode. Mode is the most repeated. So 1, 2, 3, 9 is repeated twice. So 9 is the mode. So mode is really simple to calculate. You just arrange the data and you can see that how many times one data point is being repeated. But if there are two values which are being repeated, then just take both the values and get the average of those values. Okay, simple. Now, sometimes this is about symmetry. Sometimes our histograms shows this kind of, means there's a lot of data here, lies here. So it's not a symmetry. So what is this? As I told you, this is positive skewed, or this one. This is negative skewed. Then in this case, what average we should apply? Remember, in this case, we should take the averages like mean, mostly mean. We take when we have this shape. When we have this shape, then we choose median. So remember these tips to understand. If we have a bi or tri model, like if we have this, sometimes we have data like this. This is bi model. So it's not, you should know that in what kind of cases you should take what kind of averages, okay? Or this is tri-model. Then in this case, you should choose mode, because mode is most efficient. Here, median is most efficient because it excludes the outliers. Here, mean is the most efficient measure of central tendencies, right? So you understood how to get Q1 and Q2 quartiles. Let's talk about decile. It's a similar topic. Average. So in quartile, we divide into 4 quarters. In deciles, we divide into 10 decades, right? Decades means 10 years. Yeah, so we divide into 10 parts. Each part contains 10% of the data, right? D3, so on until D9, because then the whole is 100%, so 10%. So here, what is the median? Is D5, right? How to do that? Let's see. We know the formula for Q1, Q2, Q3. That is n plus 1 by fourth value. Because we are taking the quarters, so we divide it by 4. And then 2, and then the same value, n plus 1 by 4. Then 3, n plus 1 by 4. Now you all are smart students, young, smart, energetic. So can you tell me what is D1? Simple. There we have to we divide it into 4 quarters. Here we are dividing into 10 because decile means decade. It comes from the word decade. Decade means 10 years. So that's why we divide the data distribution into 10 parts. And D2 will be 2n plus 1 by 10. Now see its value. And D5 will be 5 n plus 1 upon 10 value, which is 2. So it gives us the same as Q2, n plus 1 2th value. So remember, Q2 equals to D5 equals to median. Rest is same. After you get the arrange the data, get the n plus 1 by 2th value, then rest process gonna be same. And what is that? You just use the same formula, like whatever the value, if the n plus 2 is value between 2 numbers, so first number, first value, plus fraction, if we have fraction, then second value minus first value. So then you can calculate the D1, D2, D3, D4, D5. Remember, median, quartile, deciles, they are proportional. They are used to take the proportional or positional averages, right? It shows the position of the average, especially median. So quartile and decile and percentile also shows the respective positions of the data points into whole data. So quartile shows 4 different positions. Deciles means 10. And similarly, we're gonna go for percentile. So sometimes when you get the score, we calculate the score in percentile. What is percentile? We distribute the whole data into 100 parts, P1, P2, and so on. This one will be P50 and goes up to P99. So means everyone shows 1%. So that's percentile. So in percentile is the same thing. If we are taking P1, then P1 will be n plus 1 upon 100 value. So P2 will be 2 n plus 1 upon 100 value. So if you have a lot of data sets, then you can easily get the percentile. For example, in my class, there are 20 students, and they got like mostly the maximum score they get. That means the most intelligent student, he or she gets 70%. I'm just taking example, right? Maybe 80%. Or let's say 80%, 80%, right? So you got 81%. Okay, 81%. So, but this is percent. This is not percentile. So I have n equal to 60. So I have to see that among 60, where do you stand? Are you standing in at top, in the mid, and or the less? So in this case, let's say you are standing, you got like position number 5. You are on number 5. Like you have 4 more students above you, right? So 4 more students means I'm gonna calculate P4, which is 4 n plus 1 from 100. So what is n? 60. So 60 plus 1 times 4 divided by 100, then you can get the percentile at the 4th position, right? It means 4 people are less than you. And if you are considering 4 above you, then you have to calculate P96. So this is the 96th percentile. So in this case, 96, 60 plus 1, 61 upon 100. So when you solve this, so that will give you your percentile. If someone has a calculator, you can do it, and you can also share with me. So do you understand? Decile, percentile, quartile, and median. These are really important points, important position in distributing in in showing the distribution of different data points. Right? So have a look. Now, if I share the screen, now this one you understand. So we already talked about, the central tendency, the important points and how to calculate them. What does that interpret? What is the interpretation of these? Now we will talk about the measure of variation, different variation. Variation means how different is one point from another point. So there are different data. So what is the difference between this one? How much distance is between two different data points? So we can say that when we were talking about the center tendency, we were trying to identify the center point of the data. And in measure of important points, we aim to identify the position. So here we define center, right? Here we define, sorry, let me do it like this. So here we find center, here we find position. You should know these concepts. So that averages we take to get the center of the distribution. We take the position of the data points, that where does it lies. For this, we take median, quartile, decile, and percentile. And in center point, we can also define the average, as we can define center point as an average point. And you know that average is defined as a numeric. Average is defined as a single numeric number which represent the complete data set. So you have to make sure that we always say that according to the data set, your average must be the appropriate. Appropriate means it reflects all the data points in the distribution. Now, how to define variation? What is variation? What variation means dispersion, scatteredness. How means, as I told you, how much one point is away from another point. You have like, let's say 10 pieces of round marble, and you just throw it on the floor, and you will see when after, like, when they like stop rolling, they will have certain, they will have their certain positions, and then you can measure, you can say, oh, I can say that why did you scattered the marbles on the floor, marble balls on the floor. So scatter means dispersion, like how much away is one from another one, right? So that's the variation, how much depression is there among different data points. So how to calculate? To calculate, we have multiple methods, but actually if we divide, we can have two methods. So you have this screen, you have this thing on your PPT from last lesson, so you can take it. So this basically, there are these methods, these different methods to calculate the variation. Now we will see on the whiteboard how to do that. Just a quick, and then we can have a 10 minutes break. Okay. So now we can see, because these concepts are really important. Once you understand this, then rest is just an exercise. Then we will do many examples on Excel as well. So let me finish this one first. So as I told you, it's a scattered data sets, right? Mainly, it has two categories. I'm talking about measurement of variation. So mainly two categories: absolute and relative, right? What does absolute measure of variation or dispersion? It includes range, IQR. What is IQR? Inter quartile range. As from the name, it shows this range is overall range. We already learned that highest value minus lowest value, that is the range. So IQR means the range between different quarters, between Q1 and Q2, or Q2 and Q3, right? Variance and standard deviation. Deviation means how much it deviates. It again shows the variance, that how much away is from one point is from another. We can show it with VAR, and we can show it with SD, or we can also show it with sigma. And the other one is relative, which is coefficient of variance. Now, what's the difference? What's the difference between absolute and relative measure of variation? The main difference, absolute gives you the answer in the same measures, same units as the variable itself is. For example, if we are considering the weight of the students, so range will give us also the unit in kilograms. IQR also gives us in kilogram. Variance will give us in kilogram square. Standard deviation will give us in kilograms. So whatever, and if similarly with the stock prices, it will give us in RMB, RMB, RMB. But coefficient variance is unit free. So it can have no unit. So something which can have no unit, what does that mean? It means it is in percentage, is it in ratio? So the main difference between absolute and relative is that absolute measure gives us in a particular unit as the variable it is itself, where relatives give us the outcome in a proportion. Proportion means ratio, in a percentage. So let's begin first with absolute measures of variation, that how do we calculate properly after the 10 minutes break. Yeah. So sorry, maybe my face will be really big for you because I'm really close to the camera because I have to arrange this to the whiteboard. Okay, so have a review and just ignore my face. So I will see you in 10 minutes. Okay, bye-bye.